Hi everybody. I'm really happy to be speaking here at HalfStack. Well, here is at home, but you get what I mean. So today I'm going to be talking about doing virtual reality in the web. This isn't a new topic. Virtual reality in the web is something I've been talking about for a few years now. Previously I used to speak about you doing it with the WebXR API. But over the past few years a lot's changed. The WebXR device API is launched and has got good support. And so I'm going to be talking about making VR with the new technology that's available. Today I'm going to be showing you how I build VR and the tools and techniques that go into making a virtual reality website that works well. Before we begin, I should introduce myself. I'm a web developer advocate for the web browser Samsung Internet. Samsung Internet is a really good Android web browser with a focus on privacy and security, user-centric features, and pushing new web APIs, such as progressive web apps and WebXR. We recently added support for virtual reality through our mobile browser. But as well as being a developer advocate, I also wear a different hat. I am co-chair of the Immersive Web Working Group and the Immersive Web Community Group in the W3C. These two groups work together to produce the WebXR Device API web standard and the related web standards that support it. The WebXR Device API, like WebVR before it, supports a wide variety of virtual reality headsets. It supports tethered headsets which connect to high-powered computers. They can do high-fidelity VR, but they need an expensive piece of computing hardware to go with them. And they support standalone headsets such as the Oculus Quest, which have all of the graphics and computing capabilities contained within the headset itself. These are great because they're extremely portable, but come with the trade-off that you can have less high-fidelity experiences. The WebXR Device API also supports Google Cardboard, which is just a cardboard headset with a couple of lenses in which you put in your phone, which, whilst probably the lowest end version of the hardware, doesn't have any controllers, and the only input ability is the ability to press the button on the top of the headset. It is probably the most widely available virtual reality headset available because of its simple construction. Even today, when virtual reality headsets are more popular than ever before, probably the quickest way to get someone into VR is to send them a cardboard headset for them to put their phone into and use WebXR. The cardboard goes really well with the web. Because the web is so ubiquitous and the cardboard headset is so easy to distribute, it makes a great way to introduce people to virtual reality for their first time. So in addition to these hardware, which are the kind of hardware which WebVR was also targeting, it also supports new hardware which was out of the scope of WebVR. In addition to head-mounted virtual reality, it also supports handheld virtual reality. This is where you view the virtual reality scene through your phone and move your phone around to do virtual reality like a magic window. It also supports augmented reality, both phone augmented reality, much like Pokemon Go, where you look through your phone to see the augmented reality scene, and also headset augmented reality, where you put the headset on and the augmented content is placed on the world around you. The WebGL scene is rendered onto your walls and floor and gives you an immersive augmented reality experience. This effect is also called mixed reality, and WebXR supports all of them. It's even designed to allow you to build a single experience that supports all of these different headsets without making significant changes to your code to do so. There are many ways to do VR in the web today. Some of it involves opening up your phone and then it will prompt you to put your phone into a headset. Some of it involves browsing the web already in a virtual reality web browser. Some of it involves viewing a scene on your computer and then entering VR and then putting the headset on. And this is what it looks like through an immersive browser. I'm using Firefox Reality. I open up the website and then I press Enter VR. It takes me into the virtual reality scene where I can look around and use it. And it's really fast, and it's probably the the fastest, most seamless way to ship VR content to users. So how does it work? Well, WebXR provides representations of the position and rotation sensors from XR hardware, and it provides APIs for showing WebGL content on the hardware display. And I want to make that clear. It's for displaying WebGL content. At its core, WebXR is not designed for showing DOM content, so HTML and CSS, through the headset. There is a module which is being worked on for enabling bits of DOM content to be overlaid on certain scenes, but this is still early days yet. And at its core, anything you're going to be doing in WebXR will need to touch on WebGL. But fortunately, there are some really great WebGL libraries out there, such as A-Frame, 3JS, React 360, Play Canvas, and more. There's a lot. I'm going to be using 3JS, which is it's a very old community-supported project. It has a very large and active community and is still being very actively developed. Normally, I would use A-Frame for stuff. A-Frame lets you write VR-ready WebGL scenes with just HTML, and it's incredible. Unfortunately, it takes care of so much, I wouldn't have anything to talk about here today. So that's why I'm going to be doing my stuff with 3JS. So this is what we'll be building. This is a very simple demo with a floor, a skybox, a 3D model, and the ability to move around the scene. And my goals today will be to show you how I built the technique to move around the scene. The first thing we need to do is make a scene in 3JS with a 3D model and a floor and a sky. Unfortunately, I'm pretty limited in time and don't have time to do an introduction to 3JS. Fortunately, the community is very large and very active, and there's plenty of getting started guides for 3JS. For this scene, the sky is just a picture, and the floor is just a tiling image. The forest model I downloaded from Google Poly, which is a great resource for 3D models. It has a very large selection of Creative Commons 3D models, which you can use and as long as you attribute them back to the original creator. Once we have assembled our scene, we need to make it work in virtual reality. To do that, we need to add the Enter Virtual Reality button in 3JS. This is the button which adds the VR capabilities and tells the browser we need to enter VR. It has to be a button press. You can't just put the user into VR without any kind of interaction from them. That would be a massive security risk. After all, you could quite subtly replace the whole browser. So it has to be based on a user interaction. So here's the code for that. This line renderer.xr.enabled is really important because it tells 3GS that the graphics code needs to run on the discrete GPU. For example, my laptop has an integrated Intel GPU and a discrete NVIDIA GPU, which is more powerful and can drive a VR headset. So by having this, it makes it use the more powerful graphics card, which may use more power. This is important because the frame rate and latency timings for virtual reality are very tight. You want the shortest possible time between rendering the frame and it being shown to the user. So it has to be shown on the graphics card which the headset is connected to. The time it takes to copy across from one graphics card to another could add enough latency to make the user feel quite ill. The other line that's important is that we use renderer.setAnimationLoop. rather than the trusty request animation frame which is built into the browser we may be used to. The reason for this is because WebXR provides its own request animation frame. Because the display in the headset will often run at a very different frame rate to the display in your computer monitor. So the output has to be synced to this display, and usually at a higher frame rate, like 120 frames per second. 3GS will automatically switch from one request animation frame to the other if you use the set animation loop function. So next you want to start testing our scene. Now the most obvious way to do this would be just grabbing your VR headset and putting it on. But if, like me, you're wearing headphones or you have a ponytail, this can be really awkward to change what you're wearing or change your hairstyle just to put your headset on to try it out. Your headset could be out of power or it could be in another room. It can be a real pain in the ass to do this. So an alternative method of testing would be to use the emulator extension. The emulator extension emulates different VR headsets in the browser. It's really powerful and really fantastic. So here we have the scene I made earlier. I've opened it up in Firefox. And if I open up the inspector and I go to the WebXR panel, I now have a virtual headset and controllers I can use. So if I press enter VR, it works and it's loaded some controllers. I can move the headset. I can move the controllers. And I can even change what virtual hardware is attached. So I can change this from a HTC Vive to an Oculus Quest. And everything updates accordingly. Even the controller models change, which is actually part of my code, and I'll show you how that's done later. So this is extremely useful for developing on the go. As useful as this extension is, it just can't replace real device testing. So often, the way our developers scene is that I will build it in 3JS, and I will initially build it just as I would any other WebGL application and just testing it as normal. Once I have the VR specific use cases, I will then try it out with the WebXR emulator extension. Once I've got it working how I want to in there, I will then try it out in the real hardware. The real hardware often reveals stuff which I didn't even intend or didn't even expect. For example, my development machine is much more powerful than my VR headset. My VR headset is equivalent to a high-end Android phone, whereas my development machine has a real graphics card. Because the VR hardware was less powerful than my VR machine, stuff which my machine was doing easily, such as having a very complex floor with real-time shadows. When I was viewing it in a VR headset, I was finding a lot of lag, which was making me feel rather unwell, and making the controllers move jaggedly in front of my face. And the interesting thing is that the way I debugged this was that when I looked at the sky, everything became smooth and really nice. When I looked at the floor, everything became really jagged and not very fun to use. And it's this kind of feeling you get when you're testing it in real hardware. This feeling of whether something is good or not is hard to see just through an emulator with just a mouse and a keyboard without actually being in the scene itself. So now we have our VR scene. We've made it VR enabled, and we have a way to test it. Next, we need to add the controllers I showed you earlier. So there are two controller spaces in WebXR. There's what's known as the grip space. This is the space for whatever the user is gripping, such as the controller if you wanted to add a realistic model of the controller, or if you wanted to give them a virtual object instead of the controller, such as a spade or a sword or a wand, this is where you would attach that. And it would feel like the user was holding it in their hand. The other space is the controller space. So this is the space where if the user was pointing at something and a ray was shooting out, this is the space where the Z direction points in that way. So if you were to do some kind of ray or a projectile, it would fire out in that direction. Combining these together gives you everything you need to build a good set of interactions of either the user physically picking something up and putting their hand on it, or pointing to something and gesturing. Now we have the space to attach controller models. We might want to actually get the correct hardware control for the model. And thankfully, the Immersive Web Working Group maintains a library of assets and resources and the data mapping information from the Gamepad API to these assets. So you can work out what 3D model you need. You can get that 3D model and you can correctly map all of the information from the device to the 3D model of the device. So the user is holding in their hand a model that is represented on the screen in front of them. And not only that, all of the buttons and joysticks and touchpads will respond in the exact same way as the real hardware, which is incredibly cool and very powerful. And this functionality is also built into Three.js. So you can use the factory to get the correct model and add it to the scene. Here we're going to add it to the grip hardware. And now we have the hardware working in as we want. So if we were to go back in VR and wave it around, we would see the actual controllers we're holding in our hand in front of our face in the virtual world, which is quite incredible if you ask me. So the last part of the demo I want to build is the guideline for teleporting. This is a very useful feature. After all, the real world space that someone's in is probably a lot smaller than the virtual space, or they might be hindered by being tethered to a computer. So you want to give people a way to navigate beyond just walking around the scene. And this is where teleportation comes in. This is probably the most popular method of locomotion in VR. So the way we're going to do it here is that we're going to have a guideline that fires out the controller and droops under gravity, and where it hits the floor is where we're going to teleport. But why not a straight line? A straight line can be really awkward to hold, since you always have to be pointing it down at the floor. And for long periods of time, this can get very uncomfortable. And you may think that calculating a curve like this that seems to have physicality is going to be really complex and expensive. But fortunately, it can be calculated with little math. Our first step is to create a line made of 10 segments. We'll do this using a buffer geometry. This gives us an array of 33 numbers going XYZ, 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 where each set of 3 numbers represents the position of one of the vertices of that array. If we update this array buffer, then the line will update accordingly. So all we have to do is work out the start position, the end position, and work out the positions in between. So here is the model we're going for our physics here. And here is what we know. We know the starting position. The starting position is wherever the user is holding the controller. We know the ending height. The height is where it hits the floor. So the height is 0. We know the starting velocity. The starting velocity is, well, it's whatever we set it to. which in our case is going to be launched out the direction the controller is pointing. And for gravity, we'll set it for the same gravity as the real world, which is 9.8 meters per second down. So we're already quite far into working out where we need to be. And working out the velocity of a point in time under constant acceleration is quite a simple equation. It's just your initial velocity plus the constant acceleration, which in this case is gravity, times time. To get the position from a velocity, you can integrate the equation, which gives us this. And there's a leftover constant, c, which we need to work out. If we set the time to 0, then c is just our position at time 0, aka our starting position, which is something which we know. So we now have our formula for position at a point in time. Then we want to get to our final position. So to do that, we need to solve for when the y position is 0. But the equation we've got here is a normal quadratic equation. And thankfully, you can use the quadratic formula for solving this. So if we plug the numbers into the formula, we get this monstrosity. But this is just something we can type up in JavaScript, which looks like so. So we now have everything we need, and we can write it up in JavaScript. So our starting velocity, that we can get you from the direction the controller is pointing, which we can work out from 3JS. This is a unit vector, so it's effectively 1 meter per second, which isn't very fast. So I'm going to multiply it by 6 to make it go a bit further. We've got the controller position. We write up that equation in JavaScript. One thing I'd like to point out here, look, notice the star operator. The star operator is equivalent to math.pow. So it's a power. So instead of writing it awkwardly, I can just do it natively in JavaScript. Pretty neat that you can do that now. Now if we know our final value for t, and so if we divide that over 10 points, we now have all of the intervals we need to calculate it. We write it, each interval, into the array which we made earlier, and then we tell the geometry that it needs to update. So this actually looks kind of good. Like we now have an arc that always fires out the controller no matter where they're pointing. This isn't super useful to the user. The user wants to control when the line appears, and they want it to teleport when they release. So we need to know when the user is pressing a button on the gamepad. There are two ways to get access to the buttons on the controller. You can get access to the raw gamepad input. This is the same kind of object you'd get through the gamepad API, except instead of being exposed through the gamepad API, it's exposed on the WebXR input source itself. The other way is the select and squeeze events from the WebXR device API. There are pros and cons to both of these methods. For example, the raw gamepad input gives you every single button on the controller, but they might not be mapped to the button on the physical hardware that you expect. Whereas the select and squeeze events from the WebXR device API only give you access to those two buttons, whichever one corresponds to the squeeze and whichever one corresponds to the select, which may vary between controller through the gamepad API, but you know you'll always have the correct one if you use the events. The gamepad API is also polling based. So each frame you need to see what the current values are. And if you want to see if something changed, you have to compare it to the data from the previous frame, which can be an irritating thing to do. Whereas the select and squeeze events are event-based. You can use add event listener and just respond to the buttons being pushed. So we're going to use the select and squeeze event. So we want for when the user presses the select button, which is usually the trigger on the controller. So like a choop, choop, choop kind of motion. When they pull the trigger, we want to show the line. And when they let go, we want to teleport to wherever the line was gesturing to. When they pull the trigger, we'll add it to that controller and we'll make it visible. When they let go, then we need to teleport the user. So how are we going to do that? Well, teleporting works by working out the offset the user wants and applying that offset to their space. Because we're not actually moving the real person. We haven't invented real teleportation. We're just offsetting their position by a certain amount. We work out the offset by measuring the difference between the target position and the user's feet. It is possible to do this using the WebXR device API and creating offset reference spaces. But actually, this is kind of tricky to do and tricky to manage. And there is a simpler way. So instead of moving the user, you can effectively move the world. And we'll do this by putting the camera and controllers inside a group. And if you move that group to where you want the user to be, it has the same effect of moving the world in the opposite direction, which is exactly the behavior we need. One more advantage to creating this camera group, which contains both the controllers and the headset, is that we now have 3 spaces we can use for the user. We have stuff which is locked to the camera itself. This is head locked. Anything here, the user can't look at because it'll always be attached to the user's head. Then we have stuff which is user locked. So this is stuff which is always in the same position relative to the user. So this will be if there was an object in their real world, it wouldn't actually move when they teleport. And you can place objects, virtual objects that have the same behavior. And then you have world space, which is everything else in your virtual world. So when the user teleports around, this is the stuff that they would move away from or get closer to. You can do more complex transitions like the one in the video, where the user sees how the camera moves. This is slightly harder to make, and I'm not going to detail how to do it. But the reason I wanted to show it is to make it clear how challenging it is to build stuff like this. And not through the code. The code itself is actually pretty reasonable. But whenever you do anything that can move the camera, you can make the user prone to a feeling of seasickness. You can make the user feel ill or nauseous or want to throw up. And this is the last thing any of us want to do as developers. A lot of the popular early things to make with VR was roller coasters, but without the associated changes in momentum, the user ends up feeling really rather ill, and this is not ideal. So the things that feel comfortable in VR with motion is constant motion, aka when no force or acceleration is happening. In this example, when the camera is moving, the camera moves with no easing functions on it. It just starts moving and moves linearly to its destination and stops immediately. This is to minimize the time when the speed of the camera is changing. We also introduce an environment around the user so that in their peripheral vision, they see that they're not actually moving. It's just the view that's moving. This makes it a lot more comfortable. After I spent a day of trying to implement this feature, I was feeling really, really ill. Even after I finally got to the point where it felt comfortable, I felt nauseous for hours afterwards. And even someone who has used VR as much as I have, it really shows how important it is to build something that's comfortable for every user. And in this demo, when it's finally finished, I will probably still add an option to let users teleport with just a fade to black, because that's probably going to be most comfortable for everyone. Which, on that topic, progressive enhancement and accessibility takes on whole new levels of meaning in VR. Because not only are people using devices with different controllers, or even no controllers at all, but the users themselves may have very different abilities of motion. So some people won't be able to stand up and walk, or some people won't be able to turn around. Some people may only be able to use a single controller. Some people may be very prone to motion sickness, whereas other people may be very comfortable. Some people may be using devices which are medium-end mobile phones inside cardboard headsets. Some people could be working on high-end gaming PCs. The main power of WebXR is the ability to reach all of these different devices and all of these different people together. But that also means that the potential people you have to support is much wider. And it's best to make something that can work for everyone. The maxim mobile first applies here just as much, if not more so, than building a regular website. When building WebXR, you want to make sure you can support someone who may not have any controllers, who may be using it on a low-end device, and who may not be able to move around all that much. And if you can support that person, but also build something that works nicely for someone who's in an open space on a high-end VR headset, you can build something that works well for everyone. And it's going to give them a good experience. And this doesn't mean building something to give everyone the same experience. After all, someone who has access to two spatially tracked controllers can have a much more engaging experience than someone who can only look. But if you let someone with controllers create stuff and someone with just a headset observe stuff in VR, then that gives them both something they can do with your experience. And by reaching out to as many people as possible, we can build a VR web that should hopefully last long into the future and work for as many people as we can. I hope this talk inspires you to make something in WebXR. Even if you don't have VR hardware yourself, try getting a cardboard headset and using it with your phone, just to give yourself a taste of the immersive web. Thank you so much. I've been Ada Rose Cannon. Thank you. Goodbye.
We are going live. Give me a second. There's Ada, Tony, and myself. We are live. Thank you, Ada.
We are live. Thank you very much for that amazing talk, Ada. I'm sure it's inspired a whole bunch of people, as yours always do. And before we go into the questions, I've got a personal thank you to say to you for past talks. A couple of years ago, I saw you talk at HalfStack London, I believe. It might have even been last year. I've lost track. And it was all about A-frame. And I took the contents of that talk and turned it into a workshop to use with disadvantaged 15, 16 and 17-year-olds who were looking for a career in tech. And it really, really inspired them. So thank you for inspiring me and for allowing me to pass that on.
Wow, that's amazing to hear. Thank you so much. I'm really happy you did that. That's really, really wonderful. It makes me really happy that some good came out of the talk.
Yeah, I'm sure loads of people have got similar stories like that. So that was the past, but what about the future? So obviously you work for Samsung Internet. Is there some exciting things happening in the world of WebXR in there?
Yeah, so as well as being like involved in the standards work, we've got we're working on implementations for WebXR. So we've literally just landed support for virtual reality in 11.2, which is the one that just came out. We have augmented reality support behind a flag in 12.0, which is the one that's currently in beta in the store, and we're working on hopefully having that shipped out to stable in an upcoming version soon. So fingers crossed that it won't be long until we have both VR and AR in the browser together.
It'll be pretty awesome when that happens.
And is there anything missing from the WebXR ecosystem at the moment that is sort of blocking you from building the things that you would like to make? Is there anything you'd like to see coming up in the future?
If I have like a wish list of like community projects, it will be stuff like for making and controlling avatars, because I think social VR is really fun, and especially in this kind of time when it's hard to be physically present with someone. I think seeing someone's avatar in virtual reality is kind of the next best thing. And so if there were tools to easily create an avatar and have it animated and puppeted in VR based upon the movements of like the controller and the headset, that would be amazing. It's a really hard set of problems to solve though. So I'm not surprised no one's like fully cracked it. But Mozilla's Hubs is probably like the closest I've seen as like a single product. But if there was like a library or a service that gave you just the avatars for your own thing, that would make me so happy.
Sounds like you'll have to mix your project up with Michael's and seeing if you can get a WebXR interface controlling the puppet that he was using in his. That would be pretty exciting.
There's a lot of mashup
seeing
opportunities between our speakers that would be amazing to see. Definitely.
Yeah, seeing a lot of the talks earlier that use like computer vision to do like full body tracking, like I think that's really fascinating, because I was looking at like perhaps I could if I got enough motion capture data and like enough machine learning time, I could perhaps create an algorithm that can approximate elbows and shoulders and hips from like the head and hand positions, or at least create like a realistic looking guess that doesn't look terrible. But then seeing someone do full body tracking through the camera just kind of makes me think, well, wouldn't it be a lot easier just to set up a spare camera on the other side of the room just to record what you're doing? So yeah, that's kind of what I might take a dabble at in the future.
That sounds really exciting.
Yeah. Do you think it's realistic that we'll be able to do these things in WebXR then? And what are the limitations of WebXR, I guess, versus native?
So I think this is the kind of thing that's very doable in WebXR. Like the main drawbacks of WebXR and compared to doing XR natively is so right now it takes slightly longer for the features which are already available in native to come to the web, just because then we have to standardize on top of all of the different native implementations that are out there. So we're always slightly behind. Like the power of WebXR is the ability to ship a single experience to reach an incredibly wide audience without having to worry about supporting specific pieces of hardware, and also being future-proof. And so my hope is that the benefits you get from WebXR strongly outweigh the negative elements. So probably for stuff like video games, people are always going to want to ship something targeted at specific hardware platforms just to get the most out of the performance. But for stuff like social and shopping and education, the things where the most important thing is reaching a wide audience, I think WebXR is going to be the perfect medium.
Okay. How far away do you think that future is? So I know VR in general as a video game system, effectively, it's for playing games. When are we realistically going to be seeing mass adoption for shopping and for chat and things like that?
So we're having, like, the VR parts have pretty much landed in all evergreen browsers like over the last few months. So still early days yet in terms of like getting people to adopt it. The AR stuff is landing, and so hopefully we'll see more adoption there soon. I think part of it comes down to whether Safari supports it, because Safari can be a little slow in updating certain web APIs. So it's hard to tell, like, if Safari suddenly announces their plans to support it, I think there'll suddenly be a huge amount of adoption. Otherwise, it'll probably be more of a slow builder.
And where are we? Where is the hardware at the moment? Do we have headsets that can be worn for a long period of time? Like, what's the power like? Are they heavy? Do they get very warm?
So for VR, there's some really good hardware out there at the moment. So there's the high-end tethered headsets like the Valve Index and the the Oculus Quest. No, the Oculus Rift. Like both high-end tethered headsets, which are very popular. The standalone headsets, there's definitely a few out there, but the one that's really like claimed the market is the Oculus Quest, which I have here, and it's the one which I've seen a lot of people, even people who are just interested in VR, but not any kind of like expert, have been picking them up. Like, it's the first time I've seen a VR headset really hit the consumer market really well. They're kind of hard to get because they've been almost consistently sold out since launch, even though they keep making more. But as a headset, I can wear it for hours at a time. It's pretty heavy. It's not like the most comfortable, but it's the best I've ever had. Like, after about 4 hours of wearing it, I'm a bit tired and like I want to take a break. But yeah, it really helps that there's no wires attached, so you're not like dragging around wires attached to your head. Oh, my camera just disappeared, but I think, can you still hear me?
We can still hear you.
All right, that's fine. So yeah, even though the headset itself is quite heavy, it's very accessible, and you don't need to do any like weird, complicated setup. You can just go into any room, open it up, and draw the boundaries for where you are, so you don't accidentally walk into a wall or something, and then you can start using it. It's a good piece of hardware.
Yeah, that is the massive difference, isn't it? Being able to use it and not have to have a certain size of room.
Like, it's still popular. I'd say like the best way to, if you want to ship a VR thing to a wide audience, though, like even today, probably the best way to do it will be to send them post them a cardboard headset as well, because they're still like, it's popular, but it's still not like mass adoption to the same level as like smartphones, obviously.
I think we're about ready to wrap up and move on to our next speaker. Thank you so much, Ada, for your amazing talk and your answers, and your always amazing pursuit of making VR and AR and XR possible for the web. I just am always in awe of the things you can do with it, and look forward to see what you come up with next. Thank you.
Thank you so much for having me. It's been really great.
Yay.
Like that.